Okay, by now lots of you have these amazing little $2.69 ESP8266 Wi-Fi modules. So let's look at how to use them to connect an Arduino to Freeboard.io and graphically display the data in real time. To do this, we'll be using an Arduino Uno. It doesn't have to be an Uno. An ESP8266, the new 8266 Wi-Fi shield from www.8266.rocks, Dweet.io, and Freeboard.io. So the idea is to generate information in the Arduino, send it to the web through the ESP8266 by dweeting, and display it graphically in real time using Freeboard.io. Dweet.io is a simple and lightweight messaging service for devices. It requires no setup or sign-in, just publish and go. Send data from your thing to the cloud by dweeting it with a simple API. The bytes are characters, making up a dweet that you'd send out from a device look like this. This is the name of your thing. These are the names and values of the data that you're sending out from your thing. Altogether, this constitutes an HTTP post, which is sent through a connection you can easily make to Dweet.io. Dweeting is similar to tweeting with Twitter, but it's tweeting for devices. In the same sense that you can subscribe to a topic on Twitter by following, dweets can be received by other devices, computers, or web pages when they subscribe to your thing's data. Freeboard.io is a free visualization tool that makes it simple to connect devices and view the data they provide. Users can connect HTTP, JSON, or a Dweet-connected device to the tool and view real-time data. Freeboard allows the user to graphically build a presentation interface in minutes. Next, we need to upload the sketch that makes all this happen into the Arduino. I'm not going to get into the details of exactly how the sketch works in this video. We'll save that for another video. But I am going to show you where to get the sketch. Go to 8266.rocks. Click on Learn. Click on this link for displaying live data on the web, blah, blah, blah. And you can download the Arduino sketch here. It's on Google Drive, so it's a slightly unconventional download process. Here's the download button. And there's the sketch. So that'll get you the sketch that I'm working with right now, with a couple of exceptions. The SSID has to be set to the SSID for your network, as does the password. And you should also come up with a unique thing name here, rather than this X multiple 8s that I've used here. So set that to your own value so that all of us aren't stomping on one another's data or user interfaces. Now, because the ESP8266 is connected to the same UART, Arduino UART, that's used for uploading the sketch to the Arduino, we need to disable the TX pin on the ESP8266 during the upload. And we do this with this switch here, which is labeled Boot and Ard Upload, or Boot and Arduino Upload. We need to hold this down before we click on the upload button, and keep it down until the sketch has finished uploading. So the upload is done, and I can release it, and our sketch is now running. Now let's get things set up at Freeboard.io. To set up your account, click on Start Now. Enter this information, and you'll have an account. Once you're logged in at Freeboard, it should look something like this. And let's create a new Freeboard. Let's call it 8266 Test 1. Since I've already got an 8266 test. Here's the Freeboard, and we need to add a data source. We'll make it Dweet.io. We'll call it ESP8266 Test, and our thing name was X and 8/8. We don't need a key because this is public rather than a private setup. Click on Save and add a pane. Click on plus, select a type, and let's make this a gauge. and select a data source. Here's our data source. We'll use our ramp value for the data source. So basically we're hooked in already there. We can leave these as is, and we'll click on Save. So here's our data coming through already. Let's add another data source or another widget. Make it text and select the signal. Say yes on a spark line and click on Save. If we want our user interface to be a little more descriptive, we can click on this down arrow, this wrench, and give it a title. We'll call this ramp. Save that. Click on the wrench here and give this a title of signal. And save that. So we can keep going here, adding a number of different panes all over the screen here if we like, but this is the basics of it. Now if you want to put your new Freeboard in your own web page, copy the URL. And I like to build websites with Wix. It's free and it's HTML5, so it allows you to do some really cool stuff. There is a free app that allows you to embed an iframe or HTML in your Wix site. In order to do that, you can go to the app market, search on iframe, for example. That brings up this iframe embed, and you can add this app to your site. I've already got it added, so I don't need to do that. And now I'm going to go down to Apps, and select HTML. Here's a little section for that. I'll select Settings, and I'll just paste in that URL here. And click on Update. And there is our Freeboard. I'll click on Preview. Close this top section because we're sort of logged in there. And it's as easy as that. Just a few words about power. The ESP8266, because it's Wi-Fi, draws some high peak currents. To be safe, you can use a power supply such as this one from Adafruit and plug that directly into the shield with the power select jumper in this position. If you'd like to plug that power supply into the Arduino instead, the power select jumper should be between this pin and this pin. Oftentimes you can get away without an external power supply running right off USB, but technically you're pushing the limits of the USB specification on current if you do that. The shield can also be used standalone without an Arduino by connecting an external UART via this header using a cable such as this FTDI cable available at DigiKey, this one at Adafruit, or this one from SparkFun. These cables are also useful for connecting to the software UART on the Arduino via this header for debug purposes. The schematic for the shield is available at 8266.rocks by clicking on that. And you can buy the shield by clicking on Shop. You can either buy the kit, which has to be assembled. It doesn't include the 8266 module, or you can buy just the printed circuit board. The kit's only $12, the board's only $5. If you want to buy the board without buying the full kit, you can purchase the components themselves using these shopping carts at DigiKey. The parts are a little more expensive, but depending on whether or not you need to place a DigiKey order, it could end up being a little cheaper for you. So there we have it. Before doing this on your own setup, you should watch the videos on the sketch itself and on updating the firmware in the 8266 module. Thanks for watching.